using it right now.
Every so
Okay.
outside the box.
So a vector is an amount or magnitude, because that's another word for this, together with a direction. For example, if we have a plane traveling,
Other story problem.
no, east at 20 miles per hour, its vector would point in the direction and would have a magnitude or a length of its speed. So the vector that represents this plane would point east and has a length of 20 since that is the speed of the plane.
It's almost like a ray.
So cars
It's a
going-
ray going directionally at a certain distance, yes.
So cars going north, going up.
Yes.
This is as hard as it gets.
That's funny. A couple things that are important. The arrow points in the direction of which the object is traveling. And the length of the arrow is the vector's magnitude.
That plane going so slow.
It is.
I don't know if mine can go that.
Yeah.
If it's being hauled on a truck,
Yeah.
But then it would be a full plane.
it would be a full plane. I never said it was a big plane.
Yeah, it could be a crop dust.
You assumed it was a passenger jet.
Maybe it's a toy plane.
That one right there.
That'd be, you're not gonna get a toy plane.
On
Yeah,
a
that'd be
vehicle,
moving
it could.
Pretty quick.
I mean, like, we could be talking to a kid, hand outside the window with the toy plane, and the car's 20 miles an hour.
That's what that sign
Exactly.
was planned.
We don't know.
You just gotta think outside the box and you struggle with that.
But 70 is.
Okay, so let's look at a different thing about vectors. So this one is a little bit of a paragraph, so be prepared. Yes, you are.
She's never said that before, so. Not again. Not again. Can you just print out these notes for us?
No.
Steven,
You complain a lot. You remind me of Bill Singleton.
what's that supposed to be?
He complains a lot too. I love to.
So you remind me of the best classmate in the world.
Wish I could say the same.
Uh-huh. Uh-huh.
Is this like an example, or? We're doing an example after this.
Should we write that?
Yeah.
I have a question.
Yeah.
Do you know, like, every lesson that we do, that we will end up using? Do you know? Like, we will,
For the most part, I can tell you if you will or you will not. Of course, there are certain professions that use maybe some of these skills where others do not. So it really just depends on what you want to do. For the most part, all of this is just developing your cognitive thinking skills.
how much will I use of this? Yeah. I mean, other than.
Have you ever seen Airplane?
I've seen it.
What's your Victor vector? Like, like they talk about vectors in their pilots. So this actually will come in handy. So this just says, since every vector in a plane starts at the origin or the point 0, 0, it is uniquely determined by the coordinates of where the tip ends up. So from this set of coordinates, we can calculate the magnitude by either using the distance formula or the Pythagorean theorem. So let's start with an example of that. Let's say I have a coordinate plane, and on this coordinate plane, I have a vector v. And this vector v has a tip at point 4, 2. This 4, 2 are the coordinates of where the tip is. So we call them the coordinates of the vector. And these are what we're going to use to calculate the magnitude. So if I'm talking about the magnitude here, it helps to imagine this as a right triangle stemming from the origin. So if my vector is 4, 2, that means that this leg is 4 and this leg is 2, which allows me to calculate that hypotenuse or that diagonal using the Pythagorean theorem. Or we can just use the distance formula, which is pretty much the same thing. So my magnitude here would be equal to the square root of x squared plus y squared, where x and y are the coordinates of the tip of my vector. So this would be 16 plus 4, which comes out to be the square root of 20. So the magnitude of this vector is the square root of 20. If you're leaving it as a radical, you must reduce it. So this reduces to 2 root 5 because I can pull out a 4, or you can turn it into the decimal. It is up to you.
feel like the decimal's easier.
That's fine. If you're doing a decimal, I expect 4 decimal places.
Because I don't quite.
Do it the other way.
That's okay. You can turn it into a decimal. It's fine. So on this would be considered the magnitude of V. Either one of these. Or you could turn it into the decimal.
Square root's 1.
It's going to be somewhere between 4 and 5.
So 4.47.
That's about right.
2.1.
Any questions on that? Does that kind of make sense?
Yeah.
So that magnitude, remember, is the length of my vector, or the length of this arrow. So what we're going to do is we're going to do another one. I'm going to give you the coordinates, and you're going to find the magnitude.
I'll be rounding to, I do have a question.
4 decimal places.
4.
Can you do the decimal?
Yeah.
Everyone want crackers? Yeah.
Would it be
I don't like them.
4.4721?
No,
So label.
you would just do units because we don't know what the length is.
Okay.
So you could just say units, or you could just say magnitude equals this. That's okay too.
I think that's the first time I've ever seen exact.
Yeah.
Okay, the example I have now is you have a vector that it ends at the coordinates 7, negative 15. I would like for you to find the magnitude of V. Whenever you see a letter inside of absolute value signs, that indicates magnitude.
Two. Please type. I got a domain error.
You typed it in wrong.
16.5529.
Did you put the negative 15 in parentheses?
No.
That's why.
So
Calculators are stupid. They assume that if you're squaring a negative, if there's no parentheses, it makes your answer negative. So if I tried to do like negative 2 squared, it would give me negative 4 instead of 4. That's why.
Why would it do that to me?
Because calculators don't know necessarily what you're grouping. So that's why parentheses are important.
this part isn't.
Okay, so if I'm squaring, okay.
Is this
So
all
if I'm
done?
squaring a negative number and it comes out negative, just don't.
What would
Okay.
this be the other
What do you mean?
magnitude? Root 5. Is there a way to say?
Oh, I would have to factor tree it. I don't know. I'm not putting that kind of work into it. When we get something this big, pretty much just turn it to the decimal, it's fine. Any questions so far?
So,
Are you okay if I ask you to find the magnitude of something? Okay, so there are a couple things that we should keep in mind. The first is that magnitude is always a positive number. If you get a negative, something is wrong. The second is that velocity is equal to magnitude plus direction. And the third is that speed is equal to magnitude. In a way. So these are just helpful things that we can keep in mind as we're doing these problems.
feel like back in science.
Kind of. So now what we're gonna look at is instead of finding magnitude, because I think you guys can do that, we're gonna talk about how to put two vectors together. I know that sounds so exciting.
how do we do that then?
Why?
So like say
Are we gonna spend the whole
race.
class?
Yes.
Oh,
No, honestly, I'm gonna stop at a certain point and then we'll pick it up tomorrow.
I thought,
What is that, some French point about
yeah, man.
I made the noise, you know.
Okay, so let's talk about how to put two vectors together. When we do, we just add like coordinates. So for example, if I have a vector 1 and I have a vector 2, vector 1 would have the coordinates x1, y1, and vector 2 would have the coordinates x2, y2. When I add them together, I put the x's together and I put the y's together with this operation. So here would be addition. So this would become x1 plus x2, comma y1 plus y2. And then that would give me whatever the new vector is.
Wait, is that like the equation?
Yeah, this is like the general rule for it. We're gonna do an example with actual numbers. So sorry.
Oh, wait, never mind.
Fine.
I was gonna say, it wasn't one.
So I heard the question, when would we use this? Why would we use this? You won't use it in real life, but it would apply if we were adding two vectors together to try to figure out the end destination. For example, if I had a plane and this plane started, here and ended at this point, if they boarded another plane and ended at this point, what would be the end of their final destination, or what would be the distance from where they started to where they ended? That's what it means. Okay? So it gives that final destination or that trip, essentially, in a summarized notation.
What was the thing we did at the beginning, like last year?
I don't remember what last year
It
we
was
did.
the graphing with the two lines. There's two separate lines.
Piecewise functions?
Yeah, we gonna do that?
Yes.
Oh no.
Those are hard, dude. I had no idea. I spent like 3 hours looking at
That's all right.
videos to see any of them out.
I don't even know what you guys are
After
talking
watching
about.
Khan Academy. No, none of it.
So what we're gonna do now is we're gonna look at another application of where we could possibly use this. We're going to assume that we have a plane and we have wind, each of which has their own velocity.
I got that room for this.
Kind of. We're going to assume that the plane velocity gives the point 0, 20 for its vector, and that the wind velocity gives the point 20, 0 for its vector. Of course, I want to draw this so I can see what it's looking like. So from 0, 0, my plane is at the point 0, 20, which means it went straight up the y-axis. So that's the plane P. The wind, however, was at 20, 0, which is on the x-axis. So what I want to do is I would like to figure out the velocity of the plane in the wind, which means I need to take the plane velocity and add to it the wind velocity. And that's going to tell me where the plane ends up with the wind acting on it.
That's 2020.
But we're going to show how we get it. Yes.
2020 vision, baby.
So plane plus wind here would be my plane vector plus my wind vector. Adding like terms, we get 2020, which is where the plane will end up. I don't want to do that. I already said color already. With the wind acting on it.
I don't want to.
Does that kind of make sense? So this is where addition applies. If you want to be a pilot, this is the kind of stuff you have to think about.
Yeah.
Way complicated. So now what I want to do is I want to find the magnitude of that plane plus wind vector.
Oh, yeah. Magnitude, you say?
What do I have to know in order to calculate the magnitude? The points, right? So what are the coordinates at which my vector ends for this? 2020.
I have an answer.
Okay, hold on. So then the magnitude of plane plus wind is going to equal what, Zach?
28.284.
Anybody else get 28.2843?
What you pay? His better start raising your hand.
Yeah, I got that too.
That would be correct. So that is the magnitude of my plane plus the wind. So with the plane with the wind acting on it. But it's not super difficult.
It's just like looking at it, it kind of messes with you.
Yeah, which is why I like to do it after law of sines and cosines because they take a lot more thought, I guess. Whereas this one's a little bit more like formula or equation driven. But I think it's fun. I don't know. I like it.
It's basically A squared plus B squared.
Kind of.
So now,
What is that, Jerry?
for euro,
I don't know if I
magnitude
can
of
do it.
equals to, that's an add-on from that example.
Okay, so then what's the speed of my plane?
28 miles an hour.
The 28.2843 miles per hour. Yes.
That is-
Just to make sure you know that magnitude and speed go hand in hand.
How many knots is that?
I'm not doing that conversion. I'm not a pilot.
1.3
Okay,
miles.
questions, concerns, issues so far. How do we feel about this?
That never hurts, just looking at it, but it's.
I think it's awesome.
Think it's awesome? Okay.
Wait, so,
So basically 20 minutes.
I was like too busy like writing everything,
No,
how did you get that?
How did I get this?
Yeah.
28.
Okay. Are you okay with the 2020?
You get 2020.
Yeah, just the 020 and the 20 0 put together and got 2020.
Yeah.
So then that was my P plus W vector. To find its magnitude, I did the square root of 20 squared plus 20 squared, which came out to be the square root of 800, which came out to the 28.2843.
You just typed it.
Yeah.
28 point. That's awesome.
Wait, what?
This is 800
Oh,
squared.
yeah.
What was that?
Can you, like, move that
Doesn't
up?
matter.
Right, so
Because
it's
my
20
W
times square root of 2.
Sure.
Oh, go to classic mode. Go to classic mode.
I was debating.
It doesn't matter.
Yeah, I was gonna say.
Degree of radian doesn't matter because I'm not plugging anything in.
Use grad. Yeah, what is grad or GRD?
You're not using that, so it doesn't matter.
Yeah.
That stands for gradient.
Okay, are you guys ready for the next part?
I guess.
Yeah,
Yeah,
awesome.
tomorrow.
Wow, 49 minutes, that's good.
I don't know. Here's another example.
There is a grandma.
No.
Planets? Oh, plane.
I need a lot of room for this next time. Hold on.
What kind of plane is it?
I live. It's a fighter.
Is it a stealth bomber? Does the same rule apply to helicopters?
Are you a word behind whatever I'm writing?
No, I'm just quick. Oh,
Speed.
no. No. Wait. Oh, you draw a little thing, water.
Yeah, we have an early dismissal.
So it just be.
Okay, so what's the first thing I'm gonna do when I'm given a picture, a problem like this?
Man,
You're gonna draw a little thingy.
I'm going to pull out important information and I'm gonna draw a picture, because that helps me the most.
Yeah.
So the first thing I notice is that I'm working with north and east, so an XY for quadrant 1 will be perfect. In quadrant 1, we assume all vectors, of course, come from the origin. So my plane is traveling north, which is up, at 20 miles per hour.
Oh, we're gonna do like big numbers. 260,000 miles an hour.
Maybe, you never know.
Better not.
Which puts it at the point 0, 20. I also have wind blowing east at 10 miles per hour. So that's gonna go right. Then it's gonna be at 10, 0 for the point. And I want to know plane plus wind. How do I do that?
man,
Adam.
X plus.
Add them. Vector of the plane plus vector of the wind. So I'm gonna use V of P and V of W respectively. Vector of my plane has the coordinates 0, 20. Vector of my wind has the coordinates 10, 0. So when I put them together, I get which vector or what coordinates?
10, 20.
10, 20. So this is my vector P plus W.
How much further into this are we going to?
So what I want to do now is I want to put it on the graph because that gives me a better idea of what's happening. So vector P plus W is going to be here. I don't want to do it down. So it's vector P plus W, and is at the point 10, 20.
Are we gonna have to label like the answer when we get the answer for that miles an hour? Miles an hour?
Well, that wasn't the speed, was it?
You
No, that was just the vector. How do I find the speed now with the plane and the wind? Magnitude of that. Good. Now I need the magnitude of V of P plus W,
Which is 22.
No one is.
which comes out to be 22.1.
3, 6, 07.
Yeah, that's what I was asking. Do we put miles an hour?
And that would be MPH because that's my speed. Are we all okay so far?
I put miles or MAH, miles an hour. Miles an hour. Is that what everybody says?
I
Miles an
wanted
hour.
to find that
John, you got this. Now you got it. Squares.
Gonna give him a second. Are we all okay with this while he works through it?
Yes.
I have an additional question for this problem.
Yeah, we- okay, bring it on.
I'm so excited. I'm gonna wait till Jonah's ready.
I'm already picking up. What is the velocity? Question, we already got the answer.
I'm so excited for this question, man.
Just a question what the velocity.
Okay, ready?
22 degrees.
Yeah, okay.
60.
So my additional question is, what is the angle at which the plane is veering off course?
Wait a minute, what's half? 90. Is that it?
Just write the question.
Okay.
Where's the angle?
At which the plane is veering off course.
It's not going on.
What do you mean?
I'm gonna show you in a second.
It's a trick.
Approximately 30.
Plane traffic.
I'm gonna divide 90 by 2 real quick.
45.
I got my answer.
You're 45.
Okay, are we all done writing the question?
Yes.
So the first thing we have to do is understand what this is asking. Remember, my plane, when it took off from the airport, was traveling straight north. Did it end up straight north?
Nope.
No, the wind kind of blew it east a little bit. So this angle right here, between where the plane started and where the plane ended up, is the angle at which it veered off course. So that's what I'm gonna have to find here. I can't start with that angle though. I do not have enough information. But I do have enough information to solve for this angle and then use it to solve for that angle. So I'm gonna draw another picture just so we get an idea of this is what I'm telling you. So from where my plane ended up, I had this right triangle happening, right?
Yes. I can agree.
Why are they here?
I don't know.
So is it?
Can you go ask them if they want to come in? Okay. This is where my plane started. This is where my plane ended up. This is a side of 10. This is a side of 20 because it was at the point 10, 20. Are we all okay with that?
Yes.
My plane was supposed to be heading straight north though.
Yes.
So I need to find this angle so that I can later find this angle.
So you gotta find the side.
Mr.
Yes,
Harris wants to know if him and Matt can come.
yeah,
Like, no, like, during study hall,
when's your study hall?
right now.
That's right, we're almost done with this. Okay,
We'll let you.
so I need to solve for this green angle theta first. How in the world am I going to do that?
You gotta find
Well,
the
you
side.
cosine stuff, the stuff we just did.
Which two sides do I have?
And
You have
You have A
ways.
and
You A and B because all the.
Adjacent and opposite.
I have adjacent and opposite.
Opposite over
smart.
adjacent.
So what trig function deals with opposite and
Tangent.
adjacent sides? Tangent, good. So I can say that tangent of my angle theta equals my opposite side over my adjacent side. And then I can use tangent inverse to solve for the angle.
Why can't you use my thing?
What mode should you be in? Degree.
63.
I want a degree angle here.
63.
So when you plug it into your calculator, you're gonna have tangent inverse of 20 over 10. And we're just gonna go ahead and round this to the nearest whole number.
alright.
So 60, reality.
63.
63. Make sure you also got 63 degrees.
That's what I got. And then you just subtract 90 from 53.
And then you're gonna do 90 minus 63 to find the red angle, yes, because this was a right angle originally.
27.
Yes, so red theta here equals 27 degrees, which means our plane was 26 degrees, 27 degrees east off course. I like to put the direction, that way we get a better idea of which way it was off course. Does that make sense?
How you guys get 60?
So we did 90 minus 63 to get the 27 here.
20 divided by 10. Round to the nearest whole number.
I get 1.1.
You're in radian mode, you need to be in degree mode.
That's your problem.
Get you fixed now. Yes.
Any super duper big questions on that?
We done for the day?
We're gonna write a couple things, but then we are finished.
No, it was a little bit not too bad. I think probably the hardest thing about that was knowing what to draw for that.
Do we have to draw on the homework?
You don't have homework today.
Students, so I'm-
Tomorrow's homework, you might have to.
Well.
See that.
Okay, so what we're gonna do now is we're just gonna write the general rules for our vector operations, and then tomorrow we will start some examples. Still part of the same lesson. For each of these, we're going to assume we have two vectors. Vector 1 is gonna be x1, y1. And vector 2 is gonna be x2, y2. We're gonna start with a difference rule. For the difference, we're gonna do vector 1 minus vector 2, which is equal to x1, x2 minus y1, y2. This works the same as when we did the addition before. We subtract like, oh gosh, no, just kidding.
Son of a biscuit.
Sorry, I got ahead of myself. So this rewritten is just x1, y1 minus x2, y2. When we subtract like terms. So it's gonna be x1 minus x2, comma y1 minus y2. And then we would just simplify it to find the new difference vector. Again, these are the rules. We'll do actual numerical examples tomorrow. I just want to get these out of the way.
Alright.
So that's our difference rule. We also have the sum rule, which we already wrote down, which we're going to write again. So on this rule, I have two vectors, x1, y1 and x2, y2. When I add them together, I add like terms. So this becomes x1 plus x2, comma y1 plus y2. Again, we already wrote that one down. I just wanted to rewrite it so that all of my operations were together. And then we have something called scalar multiplication. Scalar here just means that it's one number. So for scalar multiplication, I'm going to have one number that's going to be multiplied into a vector. So we're going to do C times V1, where C is my scalar multiple. This is the same as C times my vector x1, y1. We multiply C into both of those, and my new vector becomes C times x1, comma C times y1. And then we would just reduce it from there. So these are our general rules. We will do examples tomorrow. This is all we're doing today.
Wow. Good job.